Our third speaker of the afternoon is Balram Megaveth from Broadcom Limited. He's a senior staff engineer. He's going to be telling us how to improve the quality of test benches using specialized PySlint solutions. He's 15 plus years of design verification experience. Prior to Broadcom, he worked for Microchip and Western Digital. He's worked both from IP up to SoC and subsystems. Initially worked in VIP development, network chips, mobile chips, and storage product lines. For the last 10 years, he's been mainly in wireless products, GPS and Bluetooth, Wi-Fi, SoCs. Over to you. Thanks, Balram.
Thanks, Mike. Yeah, this is Balram Megawat, and first of all, thanks to Verification Futures for inviting us. And first and foremost, I would like to thank to Srinivasan Venkatramanan. He's my friend, and he is the person behind that bringing the lint solutions in the test bench environment. And he's from the Asvigo, and Asvigo is a UK-based startup. And I would like to go through some of the background and why these lint solutions are important nowadays, and go through some case study what we have done in this using this lint checkers, and and also give you the setup and everything. And the talk I'm going to do is everything is open source, nothing is proprietary here. To start with, from the morning presentation from the Cadence says that the 60% of verification time is taking on the in terms of test plan and test bench development and the debugging. So keeping saying that, we have to reduce this time in spending more time in the development, and that we can do with some kind of solutions like this. And this is one of the lint and code analysis stuff is designed in the synopsis, saying that finding early bugs are good. When it goes to the later stages in the post-silicon, it become very costly, sometimes 100x and 400x. That's why we have to make sure that we have to find the early bugs and in terms of verification. Keeping in that sense a test bench environment with lint and UVM environment with lint and assertions and acceleration, all this code consistency and in a structured manner is very important in this flow in terms of emulations and FPGA prototypes and formals. Sometimes in the formal checks are not directly portable. If you have your own clock control logic, and if you want to port that into the formals are not acceptable. So keeping those fundamental in terms of checking is very important. I'll go through little background on the RTL linting is in terms of reliability and quality and code styling and the coding guidelines. It is very important, and fixing early bugs. This is, and if your linting is clean, that means 10% of RTL confidence you will get. That's overall confidence you will get. So some of the solutions we have in the open source RTL linting options, those are the Verilators and Icarus and Google variables, and PySlint is one of them. So it checks the naming guidelines and also coding styles and synthesis checks and the DFT checks. Many of this flow is integrated on the flow of integrated continuous integrations and continuous deployment flows. And this is one of the great open source alternative we have. So some of the challenges we have in the TB-lint in making this code coherency and the code consistency. And for these challenges are the good processes front end is very important, and that is lagging. because test benches are dynamic in nature, static tools, building on top of this is very challenging. And these are the one of the open source solutions we have, the PySlint, SVLint, and the variable open source. And this gives a flexibility and very customizable options for the test bench linting. And these are some of the links we have from the variable and also SVLint. And the talk I'm going to do today in detail way is SVLint and PySlint. PySlint is the Python-based developed on top of the PySLang. That is C++ based, again open source. We have all the links here. You can always Google from the GitHub. Yeah, these are some of the rules. Because of the time constraint, I haven't gone through many rules here, but some of the rules in terms of naming and style checks and the assertion specific and performance and specific to the functionality. For example, we have the method is not, for the class method is not extended. That is one of the rule pop up. So that is very important in terms of reusability, code consistency, and also sometimes you have a code in multiple projects and bringing together, and some security feature you wanted to add, some codes you wanted to section of code you have to highlight. That is very important. And missing labels and the constant function missing, I'm going to discuss more detail. And these are some of the UVM lints we have, missing params in the driver, and the agent is active and reusable. It will miss the reusability if you are clubbing together both active and passive together. This makes little small ones, but when you bring the IP level to the system level to the again, it makes really clean and a nicer way, and it will improve when you bring IP level to the system level overall test benches. And some monitoring is missing VIF, that means virtual interface. That is also a good check when, you know, sometimes we keep on developing the monitor and we don't care about the RTL. RTL, some of the definitions may not compatible. So RTL deals about the 4-state. For example, in monitors, you deal about the 2-state variable and club together, it will give some issues. That's why it's better to clean up all these things in early stage. I'll go through some of the case studies what we have done, and I'll see the advantages behind this. This is one of the case study. It says it's a constraint and dist issue. So this is a small constraint. So the weight is distributed between 0 to 31 and the 32 to 35,000, that one. So when you distribute equally 32 to 35,000, it doesn't make any sense. So what we have to do is distribute among the range. Weight is has to be. So instead of colon is equal, colon slash makes a lot of sense. And you may get doubt that why does people do that? But sometimes a junior engineer can do that, or if you are parsing the assertion, let's say constraints from the Excel sheet in auto checks, it will do that. There are some issues. It can pop up on 0 time. You don't need to wait for till your code coverage or functional coverage and and come across this and go back and fix your transaction. It's 0 times the violation will pop up and you can fix this. This is one of the main advantages. So I'll go through some of the case study saying that UVM agent is active, redeclared. There are a couple of issues in this this small code. This is a snapshot cut from the Cadence HBus example. For example, agent UVM. UVM agent is predefined enum type inside the UVM agent, which is predominantly extended from the UVM component. You don't need to declare there in the agent. That's one problem. Second problem is it's protected. Let's say if it is protected and if you're keeping same impression in our test bench, you cannot actually extend these defining in different ways in the upper layer like environment. That's one more issue. And if you are defining, it's mandatory to define when you are active agent or passive agent, so that gives a lot of reusability. It may be sense in the particular section when he returned the code, but when you think about the product section, these are the small things can be cleared up using these lint checks, UVM lint. So yeah, one more famous question. This is Ibi Dan from the Israel Apple team. He writes this question saying that this constraint have a problem. So with the lint solution within an hour, we got this solution check. For example, this num check is a bit type, and you are summing with the sum method and getting equal. That even go to the simulator before itself, we check this through this lint, because this num is equal to 1, that each element is 1, but the num list is list of bits. It may be zeros and ones. When you say 32-bit, when you use this num list in a different way, wrap around a different assignment, it may fail the constraint. So what we have to do is you have to use a tick and casting with the integer or a bit type or byte or anything. If you don't use that, it has a chance of failing in the later stages when you use the so you know, no need of going back up to the scoreboard and finding out that very zero time. You can also fix these kind of issues with this lint solution. And we can also do the quantitative analysis, gathering the project. This is a case study done with an example scenario which we had, and you can all based on the blocks, how many blocks you have, and the importance of that block, and you can constrain those, and you list it, how many constraints you have, how many cover groups you have, what is the how many properties you have. And this is good for the manager who wants to track all these things, and we can parse the data, and based on the priority of your block, you can say that how many constraints are here written. So if you want to add some more constraints to that block, you can add, and the manager can easily track. This is good for the manager stuff. And this is a qualitative analysis. So this is the summary behind this. So you may think that is a small issues. Why do we care? The project is working for us, and chip is doing well in the lab. But this may add some value in the fast turnaround, and fastly fix your rule in your own rule. And potentially it will help the developer. If you have your own rule, you can quickly check. And this is developed on the Python, so it is calling from TOML scripting language. You can do your own rule and add that means it's more user friendly, and it's faster turnaround, and potentially many developers are already using, and it is good. And it also gives some kind of innovation. For example, if you want to develop any APIs on top of that, if you have a clean code across the test bench, you have the scope. Yeah, tomorrow it will give the better scope. That is the advantage. So the main which I was excited about this is if you include this into your CI and CD flow, and for example, a developer is there and he's developing and checking in the test benches, and someone is managing the regression, manager is looking on top of that. So in this flow, what we can do is we can customize the things early stage, and he can manage, and once he not done any unit test on that, it can be pop up, and you can also fix in the early stages instead of waiting till end, and someone actually brings on board. In very early stage, you can free of that, and is absolutely free of license and easy to customize. And so this is the one of the main slide I wanted to go through. This is once again, this approach is based on developed on the top of PySlint, and it is Python based one, and which is eventually calling the ML TOML language on top of that. It is easily reusable, and you can write your own specific rule and properties, and you can customize whatever you want. And you can existing rule, and you do the qualitative, quantitative analysis, everything. And this is not traditionally a EDA product, and it is completely open source for the innovation. And it has quicker setup. It just takes 20 minutes to download the PySlint. PySlang is a wrapper, so you have to download that in the GitHub. I didn't give the, forgot to add that here. And make file flow, you can just add that, and you should have a Python on top of that. And you know, many style checks, and including the functional checks are there right now, and you can freely check those things. And UVM is one of the best solutions we have right now. That is available on the GitHub, and I give the links. And yeah, that concludes me saying that it will give some values to the test benches, cleaning up early stages. And when we are talking about all these AI generated, test benches, it is rethink back to our traditional way and clean up fundamental inconsistency, maintaining the code. This will eventually help in this test bench development process. And yeah, that's it. I think I'm done.
Again, save you a lot of debug time by getting